Welcome to AP Stats Period 2. We are going over one of our free response questions from Unit 3, Probability. All right. This lesson is brought to you by SOS, which we don't know. It could stand for Sailors on Shore, Stranded on Shore, or Sailors on the Sea. We're still not worried, but I'm pretty sure it means something different than that. What does it mean, Nadia? What is it? Oh, man, I don't think that's it either, but that's all right. Very good. Now, what I noticed in part A is that most students were focused on it breaking on the second time and saying, okay, that's 0.8. But in problem A, in letter A, they're actually asking you to say, first, it doesn't break, and then it breaks. So what is, if 70% is that it breaks on the first hit, what is that it doesn't break on the first hit? 30%. So it doesn't break on the first hit, but then it says each hit, it's going to increase the likelihood of breaking by adding basically 10% each time. So then I'm going to write it breaks, and the probability of that happening is 0.8, what you guys had been focusing on. So that is the answer that you're going to slot here in the table, which is what? 0.24. Now, to fill in the rest of the table, Eduardo made a tree diagram. I didn't do a tree diagram, but you absolutely can. What I first thought was, okay, if it's going to be not break, and break, then I'm going to have that it breaks on the third one. So I'm calculating the 3. So I have 0.3. 80% likely it breaks on the second one. So what is not breaking on the second one? 0.2. See how that's decreasing by 0.1? And then it breaks on the third one. So this 0.8's got to go up to 0.9. So what is 0.3 times 0.2 times 0.9? Whatever that is. 0.054. Now you could keep doing that and write 0.3 times 0.2 times 0.1 times 1, because it says it breaks on the fourth one. That's the farthest you can go there. Sure. Okay. Or you could just think, I have one left. So take these three, 0.7, 0.24, and 0.054, add them together and subtract from 1. You can also do that. It's up to you. Both will give you the same answer. It's saying you're going to break it on the fourth one. I mean, it basically, because it doesn't go to 5, that's how I know it's done at 4. Well, and I run out, right? Because of that, on the fourth one, it says 1. You're breaking on the fourth one.
But is it possible to go to 5?
I mean, in real life, yes, absolutely. Not in this problem, no. Not mathematically in this problem. I've been at a birthday party where it was like 5-year-olds were trying to break the piñata. Trust me, it went more than 4. All right?
Wait, so basically this problem is like guaranteeing, okay, for every, like on the fourth hit, it's like 100%.
Yes, because it's saying it starts at 0.7, and each time you don't break it, it goes up 10%. So 0.8, 0.9, then you get to 1, you're out of numbers. Can't go to 1.1. We don't have over 100%. So that's why it's 4. All right, and again, mathematically in this problem, that's it. But, you know, real life, it's going to be more than that. Okay, so what's that number? What? Add them all up, subtract from 1?
0.006.
Great. Everybody has that? Everybody has that down at their probability distribution table. That's what this is called. Probability distribution table for the random variable x, which represents the number of hits required for Sophia to break the piñata. Let's go to the backside. Now, interpret and calculate the expected value. So this is where you take the table, which I believe was 1 hit, was 70% likely it breaks.
Yes.
2 hits, we said, was it 0.24?
Yes.
3 hits was what was it?
0.054.
Thank you. And the last one you said was 0.006?
Yes.
You multiply the first row times the second row, and you add them together. That's how you find the expected value. Some brains think that looks good. Other students, I think it was your group, Roberto, you guys wrote 1 times 0.7 plus 2. Yeah? That's how I taught you to do it, and that's how I usually write it. I mean, it's really not. It's really mostly elementary school to here.
Does it matter which one we do?
No. They need to see something. You just writing an answer will not be enough. You need to calculate it, which means show the work. Yeah.
What if you do it a different way and still get the right answer? Do they take out?
What's another way that you did? There's no other way to do this. Yes, I'll say this, Roberto. The AP readers have a list of all different ways you can answer problems, so if your brain sees it a different way, all good. Don't worry about that. All right, so what is it? 1.36? 1.366? 1.36?
6.
2 sixes. Oh, it's rounded?
No, that's like that. That's the only kind.
Everybody got that? What does that mean? Interpret it. What does that mean? We expect Sophia. Okay, and that's perfect, Nadia, but won't give you full credit. I know. So not perfect. Yes, I guess. Sorry.
What are you guessing then?
So Nadia's statement was factually true and correct, and a great statement. A statement I've said in here. So good job. But there's something you need to say to get full credit.
That's the average.
It is the average. She said that, right? She said she expects Sophia to hit.
It's not true.
That those are the number of hits you need to break.
That's right. That's what she said. 1.366 hits to break it. Here's where they're going to get you. You must mention something about in the long run or over the long run. If she goes and tries to break hundreds or thousands of piñatas, she's got a lot of anger. Okay, Tanya? All right.
The long line number.
As she goes and breaks more and more piñatas, because can't she break the piñata in 1.366 hits? No. But if I keep track of how many hits it takes for all these piñatas that she's breaking, right, over the long run, when I average those numbers, I expect to see 1.366. Yes, I know, Roberto, that's a lot of words.
I was going to say, you have to put in the term the one that says law of the
The law of large numbers? You can keep calling it law of big numbers. The law of large numbers? I mean, that's what this is, right? Over the long run, we expect her to take... So actually, Nadia, your answer is, we can just add one little phrase and your answer will be perfect. Over the long run, or if Sophia were to break hundreds of piñatas, I expect her to need an average of 1.366 hits. Do you want me to write that down? Yes, sir. Okay. This is going to be fun. If Sophia breaks 1 million piñatas, I expect her to average 1.366 hits for each. I expect her to average 1.366 hits to break the piñatas. Is that good? Everybody okay?
Wait, so you didn't even have to mention the law of large numbers?
No, you don't. You're just over the long run. Any questions on Sophia?
Wait, so the word average, that's like essential to that?
Yeah, her to average, mean, like this expected value is the average.
Oh,
What if we just have in the long run?
I'd have to really look into what the scoring is. You're probably okay, but I'd have to really like drill down into what it says in the rubric. All right. Okay. We'll be right back.